Alright, I'm Austin Willett here, and I'm here for my Chemistry 342 Organic 2 class. I'm going to be demonstrating the ILE number 4 on the exam 3 question that we missed. I'm going to explain how to do it right. The question that I've chosen is number 20. Draw the structure of the neutral sp3 hybridized intermediate and the product formed in the Fischer esterification reaction between pentanoic acid and 1-propanol. It also asks to give the IUPAC name for the ester product and which reactant provides the oxygen atom found in the ester linkage. So I started off here, this is part of the question in brown. So I drew the structures here. This right here is pentanoic acid and this right here is your N-propanol. Your carbonyl group, first off, in the Fischer esterification is going to be protonated, and it's going to take this H from this propanol group here, and that H is going to push a pair of electrons back onto that propanol group that's going to make it neutral, and this right here is going to gain a positive charge, as we see. And as we move to the next step here, your propanol group is going to come in, and as that is protonated right here, it's going to make this carbonyl group electrophilic, which is going to make it more susceptible to nucleophilic attack. This oxygen here on your propanol group is nucleophilic, and the electrons from the oxygen group are going to attack that electrophilic carbon, which is in turn going to push a pair of electrons from the carbonyl double bond onto the oxygen, making it a neutral molecule for just the oxygen. As we move forward here, you're going to see that this propanol group that had just attacked that electrophilic carbon on the carbonyl group is going to lose a proton courtesy of this N-propanol group again, which is going to make this N-propanol group positive, as we can see over here. This right here, once this hydrogen is lost here and this forms a neutral molecule right here, this is going to be our sp3 intermediate, which was one part of the question that was asked. Then this sp3 hybridized intermediate here is going to be attacked by the N-propanol group, and it's going to form a good leaving group because this actually the oxygen is the nucleophile, and it's going to take a proton from the N-propanol group here, and down here, as you can see, it's going to form that good leaving group, which is water. And water is a good leaving group because of it's the conjugate base of a strong acid, which is the hydronium ion, which has a pKa of about -1.7, which is strong, and so it's going to be a weak base, which is a good leaving group. As you see, the oxygen, this molecule here is going to push a pair of electrons onto the water leaving group, and it's going to leave as water, which is going to reform our carbonyl group over here, but it's still going to have that proton on it, so it's going to give that oxygen a positive charge. As of course this carbonyl group here is going to have to lose that proton courtesy of the N-propanol group, which is going to come through and attack that hydrogen and take it with it. As you can see, it's going to reform that carbonyl group, and we can see as the last part of our question here states, which reactant provides the oxygen atom found in the ester linkage. That clearly came from the propanol group, so the propanol provides the oxygen in the linkage, because the alcohol group here is going to leave as a water leaving group, and the carbonyl group here is going to reform after it's protonated and then deprotonated here at the very end, as our last step demonstrates. So our last and final product will come from the pentanoic acid and the propanol, which is going to form an ester, and that name of that ester would be propylpentanoate. It's propylpentanoate because the alkyl group here has a propyl group, which comes first, and it comes from a derivative of pentanoic acid, but since it's an ether, you drop the ic on the pentanoic acid and you add a ATE, which that's going to make it propylpentanoate. So this is how you do the problem. Thank you for watching this demonstration, and I hope you enjoyed it.